You've been hearing a lot about the light microscopy module. We have here behind me the racks in which the microscope resides. Let me take you on a little tour. I'll check you out on the microscope. We'll look at some of the experiments that flew over the last year too, and some of the microscope upgrades we have in works. Come and check it out. So we're standing here in front of the FIR GIU, or Ground Integration Unit. Think of it as a lab bench onto which the LMM microscope is built. It has basic capabilities for microscopy, a digital camera, a XYZ stage, epifluorescence imaging capabilities, and we're going to be adding more over the months to come. There's a computer to control scripting the sequences of the experiment. There's power and communication to take care of the housekeeping of the experiment. Typical way to start is a crew installs a sample such as this. This has 3 strips of 5 wells each with different samples in it. This one has a magnetic stir bar in it to initiate it. A magnet will be brought up, stirred through the stir bar's rotation, and initiate the experiment. The crew would install it through an access port, close up the rack, and walk away. From that point on, we remotely control it from the ground. Everything's motorized, everything's controllable from the ground. We'll run your sequence of events, get the data down. If you like what you see, move on. If you don't, we'll tweak it. We can interactively work the experiment. Every class of samples has a different requirement for the interface. And so we have the LMM stage with a standardized interface onto which a base is placed. This base is designed for the colloids class of sample carrier, which has 15 wells for a variety of colloids, and it's placed on top underneath the objective. The very first experiment that we ran is CVB, a constrained vapor bubble, which is a heat transfer experiment. It has a very different sample configuration. It has a small vial of pentane behind a window. It has an electronic module that controls the temperature over time. Then another experiment that we're about to start very soon is the Cara experiment, or Petri plant experiment, which looks at the genetic expression of plant root attraction. This is a cases experiment. So various samples need to be initialized. This colloid sample cell has a magnetic stir bar inside, and we've in the past used a hand magnet to rotate the stir bar and mix up the sample before starting the dynamics. Some samples need a little more aggressive mixing, however. And we have this, what we call the drill mixer, which can do a lot more controlled mixing at a more aggressive pace. So this setup emulates ISS interface and a drill that's on ISS, and we just provide some bracketry. And so a drill chuck has a pair of magnets that'll spin when the trigger is depressed. And this is a very controllable way to dial in a particular RPM. Mix for a set amount of time and stop. We saw a finished sample assembly earlier, but it all starts with filling a single well in this lab here. Dina and Rick start by inserting a magnetic stir bar into the well. The magnet moves the stir bar around to initiate the sample. If we want a more robust homogenization, we have the electric drill mix. Then they followed up with injecting the sample with a micropipetter and plugging it with tiny CalRes plugs, followed by adhesive seal. This is the confocal development microscope. The confocal unit is here. It allows us to do 3D sectioning into turbid materials. It's on top of a like a RXA microscope, just like the one that's on the LMM right now, just without all the fancy flight hardening. We also have a neodymium YAG laser fiber coupled into it for illumination. We're currently developing a flight version of the laser package. One other upgrade that's in the works is a higher resolution, higher frame rate digital camera that allow us to get better imaging with the confocal unit. We're here at GRC's Telescience Support Center, where we run the fluids experiments and combustion experiments. With the exception of actually handling the samples on orbit, every step of the operations is done from this room. We run 24/7 while your samples evolve or grow. Everybody here helps with the planning. There's an awful lot of planning and coordination, but the upside is that you get an awful lot of microgravity data out of it. So why don't you come by and help us plan your experiment. We hope to see you here soon.